Hello everyone, this is the video for lesson 8.1a and we are going to talk about normal distribution and probability. And the focus on this lesson is to be able to find probability, aka percent of data within a certain range in the normal distribution. So you may notice that some of this content on the notes right here happen to be something from chapter 9. You can see right here that you have symmetric data. We have talked about the bell curve, and it just so happens that the bell curve models a normal distribution. So whenever you see something that we had previously called symmetric, and don't worry, it still is symmetric, we call that normally distributed, okay? So things that are in the real world that are typically normally distributed would be the heights of people, could be the size of things produced by machines, errors in measurements. So like if you know somebody that works in a factory, especially machinists, they have this tolerance of error where they have plus so many millimeters and minus so many millimeters that they can make a mistake. Blood pressure, you've got people at really high blood pressure, some people with really low, but the vast majority of the people are going to be kind of in the middle of that data. And then, of course, test grades. You can have just regular test grades. You can have end of course grades. You can have ACT and like SAT grades. Okay, something else that we've already studied is the fact that when you have symmetric data, the mean and the median and the mode should be very close to each other, approximately the same. If the mean and the median are different from each other, that means that your data is likely to be skewed either to the left or to the right. You know that it's already symmetric about the mean. And when it says about the mean is right smack in the middle of that data. And if you notice that you have 50% or half of the data located less than the mean, so less than the mean would be over here to the left, and then you have the other half of the data over here to the right, which means that total area under the curve would be 100%. Okay, so here's where all the new content from this new chapter comes into play. You're going to learn something called the empirical rule. Now, the empirical rule is where it's kind of like an estimated value of how much data is within so many standard deviations of the mean. And you're probably thinking, what in the world does that mean? So if you take a second, look over here at this graphic that came from your textbook. You've got a normal curve, that's your bell curve right here. And if you notice, this line right down through the middle is mu. And mu is the symbol for a population mean. So your mean is always going to go right there in the middle of your curve. And then you've got all of these little symbols right here that are being added to your mean on the right-hand side. Oops. And then you've got the same symbol that's being subtracted. Okay, and you probably don't remember, but this is a sigma symbol, that's a Greek letter, and it stands for standard deviation, and we've studied standard deviation. So if you wanted to perhaps draw a normal curve and label the mean and the standard deviations, you can very easily put your mean in the middle and then just add on the right and take away on the left. So one more time, your standard normal curve, well, not your standard, but your normal curve is basically just mean and how many standard deviations you have to the right and to the left. And if you notice, you have 3 on the right and you have 3 on the left. Something that I really do like about this picture though, do you see how that curve never quite touches that line here, that horizontal line? It's because your curve never ends. It's supposed to be infinite. So it works very much like an asymptote. It's going to get closer and closer to the line, but it never ends. But you still have 100% of the data underneath your curve. Okay, so before I make any calculations, let me just kind of reiterate what's going on here. So let's kind of scoot right here to the bottom right-hand corner, and we are going to sketch a normal distribution. And this symbol right here, remember, it is mean. So if I have a mean of 35, I'm going to put 35 right here in the middle, and I'm going to draw a line right there. I'm going to do a little bit better job. And then I have a standard deviation of 5. So this graphic already gives you 1, 2, 3 standard deviations away from the mean. Now, this graphic isn't perfect because look, that curve is actually hitting your line and it's not supposed to, but it's okay, don't worry about it. So if your standard deviation is 5, what you're going to do is you're going to add 5 to get your plus 1 standard deviations. So 1 standard deviation above the mean is 40. 2 standard deviations above the mean would be 45. All you're doing is adding 5 for each standard deviation. And each standard deviation is a line. So you've got 50. Now, typically you only measure 3 above and 3 below. Your data does continue to increase, so 50 is not the maximum, okay? It's actually positive infinity. So some people think that 50 is the biggest your data is going to get. Now I'm going to change colors and I'm going to go the other direction. So I've got 1, 2, 3 lines. So minus a standard deviation. So 1 standard deviation less than the mean is 30. 2 standard deviations less is 25. And 3 standard deviations is 20. One more time, your data does not end at 20. There is still data past the 20. It goes all the way to negative infinity, okay? All right, so let's just do some question and answer real quick. So if you've got your dry erase board, awesome. If you've got a scrap sheet of paper, great. So I'm gonna ask you some questions and let's see if you can get them right. Okay, so since 35 is the mean, what value is 2 standard deviations above the mean? So 2 standard deviations above the mean would be 45. So this is 1 standard deviation, and that's 2 standard deviations. So remember, positive standard deviations to the right, negative standard deviations to the left. Okay, next question. What is 3 standard deviations below the mean? 3 standard deviations below the mean would be 20. So this would be 1 below, 2 below, and then 3 below. All right, last question, and then we're going to get back into the empirical rule. So what would be the max and the min within 1 standard deviation? So you're going to have a low number and you're going to have a high number. So what are the 2 numbers within 1 standard deviation? So it's going to be 30 and 40. So when it says within 1 standard deviation, you're going to add 1 and take away 1. That is what within means. And that is how the empirical rule works. So let's go back up here for a second. The empirical rule states that 68% of your data, they're within, that's the key word. So it's going to be plus or minus 1 standard deviation, okay? But then you've got 95% is plus or minus within 2 standard deviations. And then almost all of your data, so you're getting really close to that 100%, but we still have just a tiny little bit outside, are going to be within 3 standard deviations. So if you look over here, it's going to be really hard for you to highlight this on your paper, so just kind of watch me on the screen. So if I wanted to highlight just the data within 1 standard deviation, so this is plus 1 standard deviation here, and this is minus 1 standard deviation. So within 1 standard deviation would be all of the data values that land between these 2 values right here. So if I go down here and I wanted to highlight that, so this is plus 1 standard deviation, and then this is minus 1. So all of the data that falls between 30 and 40 would be 68% of my whole data set. So the majority of the data is going to be located within 30 and 40 of this particular data set, okay? Now let's look at the next tier. That would be 2 standard deviations, okay? Let me change colors here. Let's do green this time. So plus 2 standard deviations is over here, minus 2 standard deviations is over here, and look, it says that you have 95% of your data. So almost all of your data is going to be right here, 95% of it, in fact. This is typically considered normal data. Anything outside that range, right here and right here, that's the data in your tail, in the tails of the normal distribution, that is considered rare data. So 95% of your data is going to be located in between those 2 values. So 95% of the data will be between 25 and 45. And then the last tier of 99.7, that's going to be between your third standard deviation below and above. So all of this between all of those two numbers right here, and those two numbers change depending on your data set and your statistics, 99.7% of that data is located in there. Now, when I say 99.7 or 95 or 68, those are all approximations. Remember, they are estimates. So it's a good predictor, but it's never ever 100% certain that you're going to have something in a very specific location. Okay. All right. So 3 standard deviations in this problem would be 20 to 50. That would be 99.7% of your data. Now, between negative infinity and positive infinity, 100% of your data. Now, I'm going to be honest with you. The math involved in this lesson is very elementary. You only have to add, subtract, and multiply. So you need a very basic scientific or just a standard calculator to do the calculations. But you absolutely need to think critically about the percents that you're trying to find. So I'm going to tell you right now, before we start practicing this, you're going to absolutely need to practice the worksheet, practice the problems that I give you. Listen to the video very carefully, because in this next section, you're going to have to start thinking. Some of these questions are very easy, very basic, but several of them you really need to think about what you're trying to do and why you're doing it, or you're going to be completely lost when it comes quiz time, test time, and benchmark time, okay? Let's go ahead and finish the rest of the front page. And it says determine if the histogram models a normal curve. So if you can draw kind of an approximate normal curve, I'm not the best at drawing these, but that's pretty darn close. So real world data is very rarely going to be perfect. It looks like the majority of the data is right here, very close to the mean and the median. So absolutely, I think that this is a normal curve. If it wasn't a normal curve, it'd be pretty obvious that you'd have most of the data over here, but that is absolutely not the case. So yes. Okay, here's what I'm talking about. It says one of the most common examples of normal distribution happens to be the distribution of scores on your ACT. So in 2010, the average score, the mean score, was 21 and the standard deviation was 5. So here's what we're going to do. We're going to label the mean and the standard deviation using symbols. So the mean is 20 and the standard deviation was 5. Okay, let me just double check. No, it wasn't 20, it was 21. Apologies. So since we know that this is normally distributed, I can go ahead and put 21 right here in the middle. I like to see the lines in my data, so I'm going to go ahead and fill those in. And then I'm going to add 5 to each one of the standard deviations to the right. So 21 plus 5 is 26, plus 5 is 31. And you don't have to show this work. I'm just putting it on here for your notes. 36, and then we're going to go the other side. You just have to subtract 5. So 16 subtract 5 is 11, and then you have 6. Remember, your data goes from negative infinity to positive infinity. It does not end at 6 and 36, okay? Now, question number 1. What percentage of students scored below 21? So if you go over here, just kind of in general, you need to know that your mean is the midpoint of your data. This is symmetric. So anything falling to the left is going to be 50%, and anything falling to the right of that mean will also be 50%. Now, it's asking you specifically, what is 21 or less? So 21 or less happens to be exactly 50%. So that's kind of one of those easy, really obvious questions that I'm talking about. You don't really have to think about it. So now let's talk about something that you do really need to think about. The second question says, what is the probability or percent? Probability and percent are the interchangeable here. What is the probability a student scored below 16? So where is the 16 located over here? Let me use a color I haven't used yet. Let's do purple. So 16 is here. And I want to draw an arrow that is less than 16. So I'm going to draw an arrow to the left. And it's going to go forever in this direction. Okay? This is less than 16. So let's talk about what we do know. I do know that 21 and over to the left is 50%. Okay? But I don't know what 16 to the left is. Okay? So here's what we're going to have to do. We're going to have to use our empirical rule and our knowledge that our normal curve is symmetric. Okay? Now I'm going to highlight this up here, but I don't want you to do it on your paper because I'm about to undo it. Okay? Now, you learned that in the empirical rule, if you have data within one standard deviation, so that means +1 and -1, all of this is a specific percent of data. What percent is that? It is 68%. Okay? Now, I promise you, I'm about to delete this. Okay? So 68% falls between 16 and 26. I don't care about 26. I only care about what's on the left-hand side, okay? So you see how my barrier is at that 16 right there? So what I can do, let me erase this. I can think, well, if I know that all the way across is 68, what is halfway across going to be? Since the data is symmetric, this side is 68% divided by 2, or 34%. Now let's think about what we just did here. Now, is the answer to the question 34%? No. But remember, I know that the left side is 50%, and I know from 21 to 16 is 34%. So if I wanted to figure out what was left over, what I would do is I would subtract 50 and 34 to figure out this missing amount. So all the way from 21, all of this right here is 50%. This part right here is 34%. What is left? Okay? Kind of making a mess on this. That's okay. We're learning. So that is a technique that you're going to use a lot. Now, at this point in the lesson, we just need practice, okay? So go ahead and get out your dry erase board, and I'm going to ask you a lot of questions. Now, if you are absent and you're watching this video for the first time, it is very important that you actually practice this. You can use scratch paper, that's fine. Please do not skip this part because it's not in your notes. This is incredibly important that you practice this before you do any of your homework. Okay, first thing I want you to do is draw a normal curve, just the generic one. It doesn't have to be pretty, but you do need to know that you have a line in the middle, that is your mean, and then you have 3 lines to the right, and then you have 3 lines to the left. Just try really hard to make them even, and make sure that you have tails past that 3rd line, okay? Now, the mean is in the middle, and that number is going to change depending on what your mean is. This is 1 standard deviation above, 2 and 3. This is 1 less, 2 less, and 3 standard deviations less than the mean, okay? So here's what I'm going to do. I'm going to give you a number. I want you to just go ahead and put 100 for the mean. So the mean is 100, and then I'm going to tell you that the standard deviation is 10. I'm going to make it really easy. Underneath these, I want you to label what each line is. So you're going to start with 100. Go ahead and label the plus side and the minus side. Pause the video and do it, and then unpause and check. Okay, so you should have 110, 120, and 130. 90, 80, and 70. Okay, so first question. What are the 2 numbers that are within 1 standard deviation? So the 2 numbers within 1 standard deviation would be 90 and 110. So you have 1 this direction and 1 that direction. Oops. What number is 2 standard deviations below the mean? That is 80. What number is 3 standard deviations above the mean? 130. What numbers are within 3 standard deviations of the mean? 70 and 130. Okay, empirical rule questions. What percent of data is within, or between, 90 and 110? What percent of data falls between 90 and 110? That is 68% of the data. How much data, or what percent of the data, falls between 70 and 130? That is 99.7%. So 70 and 130, those are within 3 standard deviations. So you've got 99.7. Now I've already asked you this one once. So if you wanted to do the mean and then just only go to 1 standard deviation out to either the left or the right, it doesn't matter. What percent is in this section between the 100 and 110? Okay, that would be half of 68. So 68 goes between here, but half of 68 would be 34%. So if that's 34%, then guess what this is? That is also 34%. So this right here, what we're doing right now, is an important skill that you're going to use a lot. So whenever they give you any kind of random number to the left or to the right of the mean, you're going to either have to use the whole 68 or half of the 68. Okay. Now, what is from the mean to 80? Okay, do you see how that went 2 standard deviations to the left? Now, while we don't readily have that number, I do understand that all the way front and, let's say, add 2 and take away 2 would be 95%. So what you have to do is you have to find half of 95. So half of 95 is 47.5%. So that would be 47.5 here. Do the same thing for 3 standard deviations. So all the way across would be 99.7. So if you were going to do, I really hate doing that. Okay, if you were going to do only half right here, so from the mean to the third, you would take 99.7 and divide that by 2, which is 49.85. Okay, so the good news is your formula sheet for your test, which you will have access to the whole time, it will give you the 68, the 95, and the 99.7%. Okay, so with that practice, let's go back over here and look at this question here. So it says, if you've got 600 students in your school, great. If they took the ACT, how many students scored between 11 and 26? Well, you can't just directly answer that question. So what you're going to want to do is figure out the percent that's between 11 and 26. That's the first step. Okay. So we're going to go over here. I'm going to erase some of this stuff because it's really busy. Okay, that looks a little bit better. So where's 11 and 26? So here's 11, and here is 26. Now, I want you to notice something. You can't do it the same way you did the last problem, because you need to work from the mean out, okay? So let's look at the mean. Now, the mean is 21, so I'm going to put a dot here at the 21, and I'm going to draw an arrow out to the 26. Now, do I know that number immediately? No, but I know what it's like to go all the way across that is 68. So what you have to do is you have to have 68. That's 34%. Now I'm going to change colors and I'm going to go from the mean back to 11. Now that I don't have that number, but I do know that I can take half of 95 because it's 2 standard deviations below. So half of 95 is 47.5%. And if I want to go all the way from 11 to 34, all the way from 11 to 26, all I have to do is add those two numbers together. Okay, and when you add them together, you get 81.5%. And they are asking how many students. So now we're ready for the second part. So now all you have to do is find 81.5% of 600 students. And just simply on your calculator, just change 81.5 into a decimal. So 0.815 of means to multiply. And then just type it in your calculator. So 0.815 times 600, we get 489 students. And it's just an estimate, but it's better than guessing. Okay, let's take a look at the second example here. We have a lineup for tickets to a local concert, has an average waiting time of 20 minutes and a standard deviation of 4. So that is enough information for me to label the mean and the standard deviations. Okay. And I like to see my lines in here, so I'm going to draw them in. And now it's going to ask me questions about the percent or the probability of this data set. So what is the probability percent of someone, let's see, that would have to wait for more than 28? So we're going to draw an arrow that is more than 28. So 28 is here. And I'm going to put a dot here, and then I'm going to do that. So more than 28. Now, is this something that I have immediately available to me? No, I don't. Notice how it's on the right-hand side of the mean. So what I'm going to do is I'm going to focus on the mean to the right. I know that 20 and above is going to automatically be 50%. Okay, so since I don't know this portion, I can probably find out that portion. So I can find out up to 28. Now, if you count, you have 2 lines above the mean, but that's only in one direction. So within 2 would be 95%, but that's above and below. So if you're going only in one direction, you have to divide it by 2 since it's symmetric, which is 47.5. So from here up to the 28 is going to be 47.5%. And what you need is what's left over. So you can just simply take 50 and subtract 47.5. And you wind up with 2.5%. Next question, it's giving you the total. So you've got 2,000 tickets in that data, or ticket buyers in the data. How many of them would you expect to wait for less than 16 minutes? So the first thing you have to do is figure out the percent that is less than 16. And then the second thing you're going to do is actually figure out the number, okay? So where is 16 in this data set? It is here. And if I wanted to draw less than 16, it would look like this. I'm working on the left-hand side, and I know from 20 to the left is a total of 50%. I do not know this, but I do have the ability to go from the mean, which is 20, out 1 standard deviation. So within a standard deviation is going to be a total of 68. but I'm only going in one direction, so that's going to give me 34%. So you have to take half of 68. So if you know this part is 34 and you know the whole entire half is 50, I would just subtract 50 and 34, which is going to give me 16%. Oh, I wrote that in the wrong spot. Now, that is a total coincidence. 16 just happens to be in the spot where it's going to have 16%. It's not at all going to be the same number, okay? You got to do your 50 minus 34. Okay, now all you got to do is find 16% of the total, which is 2,000 ticket buyers. That is going to be 0.16 times 2,000. And that's going to be 320. All right, so it's not difficult math. You just have to think about it, and you have to absolutely know that it is symmetric. You have to know how to deal with the 68, the 95, the 99.7, and you really do have to think about it every single time they ask a new question. Here's what I want you to do. I want you to pause the video, and I want you to figure out if 1 through 4 is either true or false. Unpause it, and we'll check your answers. Okay, question number 1 is definitely going to be false because real-world data is very rarely perfect, and that's why it's going to be false. Question number 2, the mean, the median, and the mode are approximately equal when it's normal. This is absolutely true. If it was skewed, then the mean would either be greater than or less than, or it is likely to be skewed if that was the case. Question number 3, the empirical rule is more accurate than using technology. Now, we didn't use calculators to calculate the probabilities. You would typically do that in a statistics class. Using the empirical rule, you are rounding. So if you use technology, technology is going to be more accurate, so the statement is false. And then in a normal distribution, more than 86% of the data is within 1 standard deviation. As far as I know, within 1 standard deviation is 68% of the data. Okay, so please, please, please do not copy the answers. They are posted on Google Classroom. Do as much as you possibly can on your own, and then click on the answers in Google Classroom and then see how you did. And just let me know if you have any questions.